Today, before we talk about vectors, I have a question. I'm going to write down an expression, and I want you to speak the expression back to me without spelling it, because that's not how we communicate. You don't just S-P-E-L-L space T-O space E-A-C-H space O-T-H-E-R. That is not how we communicate. You've got to read what I write so that I write it down. Speak what I write. How would you read this in words? Think about how you would read this in words. You want to volunteer? Some of you might be, I'll do a multiple choice style. How many of you would look at this and say 2 times x minus 5? Did you say 2 times x minus 5? Why is 2 times x minus 5 not going to make me write this? If you say 2 times x minus 5, am I only able to write this? No. I'll write 2 times x minus 5. That's what you said, isn't it? That's exactly what you said, 2 times x minus 5. Anyone want to suggest a fix? Some of you might be all the quantity in thinking that you'll open up parentheses. So some of you might be thinking, I've got to fix 2 times the quantity, x minus 5. What's the problem with that statement? Doesn't the quantity open up parentheses? Doesn't the saying the quantity, doesn't that fix it? We could interpret this by saying the quantity opens up parentheses, but what's the problem with saying the quantity and implying that it opens up parentheses? What's missing from that? If we open up parentheses with the quantity, where does it end? When did I end the parentheses? I didn't. It'd be perfectly reasonable to look at 2 times the quantity x, write 2x, and then subtract 5. And people would be wondering, why are you saying the quantity? I'm not talking about you understanding that the quantity x minus 5 puts x minus 5 together in parentheses. That requires you being brought up in a system that teaches you that this is okay, and it is still unclear communication. Does that make sense? Saying the quantity, not good enough. Because you could still say, here's the quantity, here's 2 times the quantity x, and then minus 5, and we're still in that situation. You could say 2 open parentheses x minus 5 close parentheses, but now you're just spelling the expression. And that is also not how we communicate. Questions? So that's the question. How do we pronounce this set of symbols? 2 parentheses x minus 5 close parentheses, not this spell it. Okay. Oh, awesome. The product of 2 and the difference of x and 5. The product of 2 and the difference. And that is what sets up parentheses with a beginning and an end. So nice job. Correct answer coming in from the chat. Thank you. See how do I put it there? So you could say, instead of product, since the 2 is right in front, you could say 2 times the difference. All of a sudden, I can't spell difference. In this version, we say 2 times the difference. So the thing that we're multiplying is the difference. And so you write the difference between x and 5. That is x minus 5. And I want 2 times that difference. And so this wording puts parentheses around the x minus 5 and multiplies that result by 2. Technically, you could have also said 2 times x minus 10. Because I think in a spelling bee, if you spell a synonym, that should count. In the spelling bee, they're like all spelled yacht. It'd be like all B-O-A-T. And if they're all, that's not quite right, then be like, oh, okay, E-X-P-E-N-S-I-D-E space B-O-A-T. If you can spell a synonym, I think that should count. But if the design brief is to say, write this very specific phrase that spells 2 parentheses x minus 5 close parentheses, then there's only, or then this is one way to say it. Any questions? Like I said, algebra is a reading exercise. It's not about order of operations or PEMDAS. First thing in PEMDAS is parentheses, and parentheses is not an operation. So what's it doing in the order of operations? Also, multiplication and division are the same thing. They happen at the same time, going from left to right. You ever see those things on social media? It says, what's the answer? And then they give you an order of operations question. What's the most recent one? 6 divided by 2 times 1 plus 2. And then an argument ensues. How many people have seen this? An argument ensues. Here's the important thing to realize about this question. Not whether the answer is whatever the 2 things people get. This question was not posed so that you would do the order of operations and come up with an answer. What was the reason for posting this on social media? This is an important thing to know because you all are math people. You all are mathematicians now. You're going to be called upon to come in and make a ruling on this because of your experience and your education. And there is one correct answer. But it's not a math question. Go ahead. No, it's not even about whatever gets the most comments. Whoever put this question out on social media does not care what the answer is. They just know half of you is going to answer one way, the other half is going to answer the other. And then one side is going to call the other idiots. Then the second side, being insulted, will insult the first side. This is not a math question. This is someone trying to start a fight. It's important that you realize that when someone poses this question, they give not one shit about the answer. They just want to start a fight. Not like a physical fight, like an argument on the internet. That's the important thing to notice. Not what is the correct answer, what isn't the correct answer, not why one answer is better than the other. The objective of this problem is to start a fight. And so the correct answer is to not get involved. Walk away. Because the fact is, if I want you to do 6 divided by 2 first, which I do if we read the order of operations, I can remove all doubt. I can say, you know what? I can improve on this question. I can improve my communication because I could do this. Six divided by 2 is 3, 1 plus 2 is 3, 3 times 3 is 9. There is no other way to interpret this. If I actually cared about coming up with the answer, this is what I would have written. I would have put parentheses around the 6 divided by 2. Strictly speaking, they're not necessary, but you know what it does? It removes any question about what I want you to do first. This one is a math question. Putting parentheses around the 6 divided by 2, that's a math question. Leaving the parentheses off is trying to start a fight. This is a question worth answering. If you want the answer to be 1, remove all doubt. It says, I want you to do the division afterwards. I want you to multiply 2 times 1 plus 2 first. First one is 9, second one is 1, no question about it. Wait, 1, right? Yeah, 3 times 2 is 6. No question about it. The way that the question was asked, it's clear someone just wants to start a fight on the internet. They didn't come back to see who answered 9 and who answered 1 and who answered 45 for whatever reason. They just came to see people fighting. Don't participate in that bullshit. It was deliberately written to be unclear and take advantage of people's ignorance. Sound familiar? Deliberately phrased to incite an emotional response. As soon as you see someone posing questions, just asking questions, as soon as you see someone trying to provoke an emotional response, shun them. And make sure your friends shun them too. You're just trying to piss me off, so you can fuck off. And I would argue that anybody that is just asking questions is just trying to piss you off. If you have a friend that does that, they shouldn't be your friend anymore. If you're the friend that does that, you need to stop. You're being disingenuous. You know what I mean? This might be beyond the purview, let's say, of Calc 3, because it's an algebra topic, I guess. But it is not beyond the purview of critical thinking, which all the classes at Skyline fall on. Because we have institutional student learning outcomes, and one of them is critical thinking. And an important aspect of critical thinking is to see if someone is actually, honestly asking a question, or if they're just trying to start a fight. You know what I mean? Any questions? And in every case, PEMDAS is trash. How's everybody okay? How did that happen? I'm trying to trace back where I ended, how I ended up here. Because I walked in the room thinking, I'm going to talk about vectors. And then my attention span, oh, ho, ho, you are not, Professor Leach, going to talk about vectors today. And I was like sitting here setting up my stuff. I'm like, oh, screw you, attention span. I'm totally going to talk about. Throwing me off because I parked over here yesterday and I looked out the window, I'm like, oh, what is my car doing over on this side? And I completely forgot that I made the conscious decision this morning to park here because it's technically close to my office, insofar as there are fewer stairs. Anyway, easily distracted, I guess. While you are working on functions of 2 variables and equations in 3 variables, we need to start talking about vectors. We need to talk about why we need to talk about vectors too. So let's talk about vectors. For those of you following along in the book, this is in chapter 13. Actually, it's in chapter 13 whether you're following along in the book or not. So today, we want to talk about vectors. The reason that why we want to talk about vectors actually came up yesterday. Because yesterday we started talking about derivatives in the x direction and derivatives in the y direction. So recall we talked about derivatives in the x direction and derivatives in the y direction. But that's only two directions in a two-dimensional plane. And there are infinitely many directions in a two-dimensional plane. It's not just left and right, forward and backward. It's all the combinations of those directions. So it's important that we have some common way of talking about directions that aren't just the cardinal directions, left and right, forward and back. So vectors is a way that we can combine these cardinal directions into any direction that we want. So if we want to start talking about derivatives in any direction, not just the x direction or the y direction, but derivatives in some combination of these two directions, that's why we're going to need vectors. Here's the good part. Vectors come up a lot. If you took physics, you encountered vectors. If you took linear algebra, you encountered vectors. Now that you're in Calc 3, you're going to encounter vectors. If this is the first of those three classes that you took, welcome to vectors. If it's the third, welcome back to vectors. So let's talk about vectors. A vector is a quantity with magnitude and direction. Scalars are just magnitudes. Vectors have magnitude and direction. A vector is a quantity with magnitude and direction. The other word we're going to use for magnitude is length. So magnitude is just going to be length. This is opposed to a scalar, which is just magnitude. So a vector is a quantity with magnitude and direction. A scalar is just magnitude. For our purposes, scalars are going to be real numbers. This is calculus which is built on real analysis, and the real refers to the real numbers. In a general sense, the scalars can come from any field. But in this class, the field that we're always going to be using is the real numbers. So a scalar, the scalars that we're going to be using are the real numbers. So the scalars that we're going to use are the real numbers. Another field that we could use here is the complex numbers. But that would be the purview of complex analysis, which is just calculus, but with complex numbers. So for now, we're just going to stick to real calculus. Real in the sense of real numbers, not real versus fake. We're going to imagine vectors as arrows. We're going to imagine vectors as arrows. We're going to give vectors letter names, but we're going to put an arrow over it to say that this vector v, this quantity v is a vector. So when we write vector names, we put arrows above written vector names. Sometimes if we're typing, we will just use bold instead of italic for vector names. So arrows above written vector names, just bold. But I don't have a bold-faced pen. So instead of writing a bold-faced V, I put an arrow on top of it to let my reader know that this quantity V is a vector. There are going to be a couple of ways that we describe vectors. We're going to break vectors into horizontal and vertical components. One of the main ways that we're going to describe vectors is to break them into horizontal and vertical components and say that V is the sum of the horizontal component and a vertical component. This contains a lot of information. This is how we're going to add vectors. The vector V is just the sum of its horizontal component and its vertical component. Sometimes we like to think of vectors as forces. So for example, if the horizontal component is us rowing a boat through across a river, and the vertical component is what the river is doing, then the vector is going to be the sum of those two. And that will represent our actual path as we try to row across the river. So just by writing this vector V at an angle with the horizontal and vertical components, we talked about how we're going to communicate vectors, and I've talked about vector addition. We got to think about how we're going to describe vectors. And we're going to start with some unit vectors. There's going to be our basic horizontal component and our basic vertical components. Our base horizontal component is going to be I, and then we're going to put a hat on it. So if we put like an arrow above the I, we read that as I hat. I think this was invented to make instructors look ridiculous, or at least sound ridiculous, when we start talking about vectors. It's just like, well, I hat. I'm going to say the horizontal vector I hat is the vector 1, 0. Yep. Our horizontal component will be a scalar multiple of this unit vector. I forgot to write scalar multiple of. So we've got 5 in the horizontal direction. That would be 5 times this vector. And that'll be 5 on the 0. Our vertical component will be some scalar multiple of the vector j hat. And now I can describe any direction in the plane. Some amount of I hat and some amount of j hat. I just take scalar multiples of the I and the j and then add them together. If we're working with 3-dimensional vectors, then we just write these as 1, 0, 0, 0, 1, 0, and then we add a third one with a 0, 0, 1. And we call that k hat. If we have to move all the way up to R4, I guess we could have an L hat, but we don't normally. This IJK notation really seems to be focused on being in physics, and physics is mostly concerned with R3. Any questions? Anybody who's never seen I, J, and K, the directions of vectors are basis vectors? How many of you anybody been through linear algebra? In linear algebra, we write them up and down, but it's the same thing. Instead of writing 1, 0, we write 1, 0, or 0, 1, 0, we just write 0, 1, 0. And then instead of the pointy brackets, because pointy brackets get way too wide, if we have tall vectors, we use square brackets. Any questions? No, I think linear algebra is easier than calculus. I think the big advantage is it's mechanically simple. Because your introductory linear algebra course, which here would be Math 270, you pretty much have one operation. Find the reduced echelon form of a matrix. Once you find the reduced echelon form of the matrix, it's just a matter of reading what the matrix is telling you. And the best part is, oh, did I have it? Oh, I do have it. Your graphing calculator, although your graphing calculator is terrible at making graphs, it is really good at finding the reduced echelon form of a matrix. So once you ask your calculator for the reduced echelon form of a matrix, then you just have to learn how to read the matrix. So in that regard, linear algebra is really simple. As far as how it compares to calculus, you got to think about what your strength in calculus is. If when a problem set comes along and in calculus, and it's like, I'll find the indefinite integral of these 1,000 integrals. And you're like, oh, no problem. This is going to be boring, but it'll be easy. I just have to grind out problems. If that's your strength in calculus, that doesn't apply as much in linear algebra. If that kind of assignment where it's in problems 1 through 50, do the thing over and over again. If you hate that assignment, but you like when the problems say, in problems 1 through 10, interpret the result. If that is your strength in calculus, then linear algebra is going to be easier class. Because it's all about looking at the reduced echelon form of a matrix, seeing where the pivots are, and deciding what that is telling you about a linear system. The other clue that linear algebra is easy, it's got linear in the title. Once you're dealing with linear equations, everything is flat. No sudden curves, like a parabola, just out of nowhere. No exponential stuff. Everything is flat. It's a point, it's a line, it's a plane, it's a three-dimensional Euclidean space. Everything is super organized and easy to follow. So in that sense, it's easy. But if when the teacher says explain, and you're like, oh man, no, then linear algebra is going to be more difficult. So it all depends on what you like and what you can get along with. Good question. And some of you might be taking that over the summer. Not anymore. Last summer was not last summer though. So it's a good class to take during the summer though, because it's pretty straightforward. It's pretty easy class. Like the idea of taking physics, any of the physics classes during the summer, that sounds awful, right? I heard I heard some schools offer organic chemistry during the summer, and I'm like, oh no, partially because it's organic chemistry, but I don't want to take a class that I struggle with so much and then compress it down into 1/3 the time. That sounds like a bad idea. But linear algebra is nice and straightforward, and the compressed schedule actually helps because you just have to be fast and efficient. And you learn one operation that your calculator can do, then you spend the rest of the time reading the bones. These are just like a seer. We consult the bones. Where do you do that? It's in the matrix menu under math. All right. We're going to spend the rest of the week talking about vectors. So read up on chapter 13, get started on that homework. That's it for today. I'll see you all on tomorrow. Everybody have a good day. Thanks for playing.